Kia ora koutou. In this video I'm going to do some harder implicit differentiation stuff. So we're going to start looking at quite cool curves that are not functions, like this one here, and we're going to see what we can do with it. So this curve is brought to you by the following equation. X times e to the y minus cos y is equal to 1. Now we could still split the x's and the y's up in this one, just like we could in the easy ones in video 1. And we're going to look at how to do it that way. Right? So in here we'd get x e to the y is equal to 1 plus cos y, and then we get x is equal to 1 plus cos y over e to the y. So if I said I want to know the gradient at this point here, which has got coordinates 2, 0, which is what I'm going to do in the first bit of this video, how would I do that? Well, I've got a clear link between x and y. I can't find y as blah 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 in terms of x, but that doesn't matter. I've got enough that I could go ahead and find this, dx by dy. So to do that, we would do, I'm just going to start this, I'm not going to finish it, but we'd do the quotient rule, right? We'd do this squared, copy this up, differentiate this top line. Oh, I just about am going to finish it. No, I'm not. Okay, so you go on like that. You get an expression for dx by dy. And then to go from that to dy by dx, it's really simple, but I want to spend time talking about this in class, not here. We can use this relationship, and this comes in useful in so many more complicated problems, right? So that dy by dx is just 1 over dx by dy. Right, so let's now have a look at how we could do this using implicit. So the goal is to find the gradient of the curve just at this point 2, 0. Okay, we can see that there are a whole lot of other points where x is 2, but we're not interested in those. We're keeping it simple. We want to find the gradient here. Okay, so implicit differentiation works like this. We've got x e to the y minus cos y equals 1. This is a product, so I need to apply the product rule. Differentiating by term, I get the first x times the derivative of this with respect to x. So that's going to be e to the power of y times dy by dx, plus the other way around. The derivative of this, which is 1 times the second function, e to the y, and now I have to differentiate this with respect to x. So that's going to give me plus sine y times dy by dx equals 0. Okay, so there are quite a few things in there that we've only just learned in the last week, right? This bit here is the product rule, and then this bit here is a trig derivative. So Education Perfect is great for all of this. Lots of nice slow practice. So now we can collect up terms, and we're going to get dy by dx into x e to the y plus sine y is equal to negative e to the y. So dy by dx is negative e to the y over this. And you can see that I've got the x's and the y's mixed up. But I really don't care about that, because all I'm asked to do is to find the gradient at the point 2, 0. So that equals negative e to the 0 over 2 times e to the 0 plus sine of 0, which gives me negative 1 over 2 plus 0, which is negative 1/2. Let's go back to our graph and have a look and see if that's right. No, wrong graph. Here we are. Yep, that looks perfect, right? So here's my tangent line here with a slope of negative 1/2. Now you can go on now and do exercise 4D, but I just want to make sure that you know that the work solutions for that are up, and if you get stuck on any of them, because it's quite a hard exercise, please send me an email if you're working from home, or leave a comment on Google Classroom. But probably emailing me is going to be best. Alright, so thanks for watching. This is a topic that we're going to come back to over and over again over the next few months, so it's well worth making sure that you've done heaps and heaps of practice at it.